Hello, friends. Welcome to the first episode of House of Code. I'm your host, Corey House. Today, we're chatting with AI researcher and consultant and a good friend of mine, Matthew Renze. Matthew is founder of Renze Consulting and the president of Renze AI Research Institute, where he researches cognitive architectures for AI agents. Matthew has a master's of science in artificial intelligence from Johns Hopkins University and a bachelor of science in computer science from Iowa State University. He's a Microsoft MVP, a regional director, an author for Pluralsight, Udemy, and Skillshare, and founder of the Las Vegas AI Meetup. That's a list, man. Matthew, thanks for joining me.
Thanks for having me, Corey.
So this conversation started because this morning I got up and just was very honest on Twitter talking about my worries about the future of software development and my career. And it started a nice conversation. And you are somebody who I really respect in this field, and especially because you're doing research in particular. So I want to just kick this off with me making a confession. I'm worried about the future of software development, what my career might look like. Should I be?
Well, I think it's right to be worried. Like anytime we have any change, there's obviously going to be some worry and fear in that. But I think the antidote to that fear is preparation. And so I think if you're preparing yourself for what's coming and coming very fast, you don't really need to worry. But if you're unprepared, or more importantly, if you refuse to prepare because you don't think this is real or this isn't going to be that big of a deal or it's just a hype cycle and it's going to go away, I think you're going to be sorely disappointed in a few years when the world around you as a software developer is almost unrecognizable.
Yeah, that. So you say unrecognizable.
Yeah.
What are some things that you see in the future that a lot of people might not envision today?
Well, I think the role of the software developer is going to change fundamentally in the next few years. And software as we know it, it's going to be really hard to refer to as applications. These things are going to become agents. And the role of software developers will likely be to build these agents and teach these agents, and then make sure that these agents are working or behaving as they're supposed to.
So help me understand the difference between an application and an agent.
So if you think about an application, you've got a human being interfacing with something we call an application to get the computer to do work in order to solve the problem. Highly interactive feedback loop. You're, typing stuff in Microsoft Word and it's giving you feedback. Oh, here's, how you indented and bulleted this paragraph. Really rapid feedback. But in the near future, we're most likely going to have software agents instead. They're already starting to build these. They're not great. They've got some problems, but it's the direction things are going. And especially if you talk at leadership at like Microsoft or OpenAI, they're convinced that this is the next big thing in the software industry. So an agent, on the other hand, is there's a couple ways to build them, but the way that's taking off right now is you've got a large language model as the engine of computation, if you will. And the large language model, like a chat bot, it can receive text and then it produces text as an output. But rather than having a conversation with a human being, the agent is set up, or the large language model is set up to receive the state of the environment as a textual description. And by environment, this could be anything from a database to like complex math simulation, or even driving, like being a robot in a body or anything like that. So any environment, it receives the state of the environment as text. And then it creates a chain of thought, which we already do with large language models. Think step by step. How would you solve this problem? Come up with a plan and then execute each step of the plan. And then it can choose an action, which the actions are typically, it writes some code or talks to an API or makes a database query or does something. It executes some text-based command in its environment. And then that changes the state of the environment. So it receives feedback about the changed environment as text again, and then just repeats this observation, thought, action, change the state of the environment, and then use that feedback in that loop over and over again. And so in the future, we're not going to have applications like they are, I don't think. We're going to have these agents, and we're going to be having dialogues with them. But the agents are going to we'll tell the agent what we need done, and we'll give it some parameters, say, optimize this subject to this set of constraints. And then I'm trying to think, create an email marketing campaign that, promotes our new product, but don't spam people and make it sound professional, like those kind of things. You set an objective subject to a set of constraints. Then it goes and it builds a plan for how to complete this. And then it will start executing step by step through that loop we discussed. And anytime it needs a human to either approve of something because it believes it's a bit risky to do, or doesn't know how to do it, or can't legally do it, then it will say, "Hey, I need you to help me with this." And that can either be via, a prompt, a notification that pops up on your computer, a text, an email, however you tell it to get a hold of you. And you can also prioritize the severity. Like, if this is a bad thing, call me right away. If this can wait until Monday, just shoot me an email, kind of thing. And so they're going to go and they're going to ask humans for permission to do things, but there will always be humans overseeing this process. I don't see that going away anytime soon. But for the users of applications, what they're doing is going to be very different than what they're currently doing. I imagine, working with a computer in the future is going to be more like um, talking to another person rather than controlling a machine. For example, if you're trying to build oh, it's my daughter's birthday party, I need to create a banner. She likes unicorns. You just literally just say that to the computer, and it's like, oh, here's 3 different options. Which do you like best? We'll iterate on that. Oh, that one right there. But make the title a bit bigger, and move the unicorn over to the side. And I'm not saying you're dragging a mouse and doing this. You're literally just gesturing to it. And it's like, oh, okay, how do you like this revision? Oh, that's great. Yeah, go ahead and send out the birthday invite or whatever. Sure, their birthday invites are set. Let me know when so-and-so accepts the invitation or whatever. Like, so those kind of interactions with the computer, I think, are going to be normal. And working through an IDE or a application will feel like a manual typewriter by comparison to an electronic word processor or working with a computer.
So I think that paints both an exciting vision and a concerning vision. And that's the mixture of AI. Anytime that you have innovation, there's going to be winners and losers there. And I can't help but think that what you've just described there sounds a lot like the way any boss would speak to a software developer today. It is, I think, natural language. You're saying, here's what I need. And that's where it speaks to what sounds like a future where prompt engineering is the term that I've heard, where you're getting good at telling AIs what you want. But I'm unclear how much this idea of prompt engineering is different from this idea of working with an AI agent. How can you help me connect the dots between those two ideas?
Yeah, you're definitely going in the right direction, though I might make some slight modifications to how you word it. Okay. I think in the future, every software developer will essentially be a project manager, a highly technical project manager. Our job as software developers or technical project managers, or whatever the new title is going to be, AI-assisted product supervisor or something, our job is actually going to be to specify a set of objectives, like the business, essentially like, the business analysts are doing right now. Here's the domain of business. Here are the constraints that you need to be subject to. Here's your objective. I want you to optimize X. And so it's going to begin, it'll go off a set of these agents. We'll start writing code. It'll start bringing stuff back to you and say like, hey, what do you think about this user interface? Oh yeah, that's great. But, move the button here and make it blue, kind of stuff. All right. They'll come back in, 10 minutes and then, hey, here's our new update. And the same thing with code. It's like, well, we have to talk to these APIs, should we do it this way? Should we do it that way? You'll just give them advice. So essentially they're doing all of the work. We're just kind of nudging them in the right direction and making sure they don't go, off and do something we don't want, because machines are extremely good at doing what you tell them, but they're not great at understanding edge cases, at least right now. So if you tell them to vacuum the entire house, if your robot vacuums on the roof, that's your fault, because you did say vacuum the entire house. You didn't say just the floors inside of my house. And so, yeah, I think in the future, software development will be, we become managers of software agents that are building the software. And then we're essentially making sure the software is built the right way. We're helping them. They'll be, testing their own software, but we'll be verifying all of the tests. We'll be using feedback in order to improve the process. There's just a whole slew of things. There's a lot of work yet to be done. It's just going to be very different than, typing the code yourself. Once again, it's very similar, if you think about it, to like manual processes, or like at one point in time, we wrote code in assembly, and like I've written assembly code. It is really tough to do because, well, for reasons, but writing software today compared to when I first started, it's a completely different ballgame. And now that we have AI tools assisting us, it's just completely different than it was when I started.
Yeah, I can't help but think about, we have continued to have higher level abstractions as software developers over the years. And I remember people being worried about seeing drag and drop interfaces and thinking, okay, is this going to kill software development? And honestly, I had that concern at one point too, because demos looked so impressive. And then it turned out those demos weren't as, there's always edge cases that we can't see. And what I can't get a sense of right now is, it's weird. I talk to some friends of mine that are using AI on a daily basis, and some of them are concerned like me, and then others look at the whole thing and see it as wildly overhyped.
Yep.
And I've got to imagine that your take on where we are right now is probably a mixture of those things. Can you give me a sense of overhype? I assume you agree. We're right now, the hype cycle feels like it's really up on AI. What are some aspects of it that you see as overhyped?
So I agree. There's actually a lot of hype in the industry right now. And if you know the history of artificial intelligence, we've been through two previous hype cycles. There was a symbolic AI boom and bust, and then we had the expert system boom and bust, which if you look at Microsoft's hesitation to use the word AI in any of their Azure products for years, that's why it existed, because so many people were still there from the expert systems crash that the word AI was essentially anathema in the software industry, which once again is why we ended up with everybody calling it machine learning. And then we had deep learning. And, now we have large language models and generative, like it's all AI. It's just different phases of AI. So there's a lot of marketing involved, which leads to a lot of hype. And we've got a lot of snake oil salesmen, and you have to really watch out for them. But, they're good at what they do. So it's hard to tease out the people who actually know what they're talking about versus the snake oil salesman. So yes, there's a lot of hype. Some of the things that I think are overhyped. So the abilities of large language models are overhyped, but because I don't think any of us expected them to work this well, even in like the experts in the AI field, like it just was very surprising when GPT-2 started to exhibit like zero shot prompting, where essentially you didn't have to show it a bunch of examples of what needed to be done for it to do a task. You just said, oh, hey, do this thing. You just say what you wanted, and it somehow figured it out. By the time we got to GPT 3.5, I mean, it was just like, okay, yeah, there's something here. And I started with GPT-2. That's where I first got into working with large language models. And so that jump was big. And I think that's when most people woke up to this. So, like you have machines that can barely do anything to like, oh, wow, it's actually able to do something impressive. But that also leads people to assume that they can do way more than they actually can. Because right now, large language models, they're not good at reasoning. And so you can make them do a lot of tasks, but if you think they're going to solve all of your problems in your business, I mean, they're not a magic silver bullet. They require a lot of prompt engineering. A lot of guardrails have to be put on things. They have to be used in low risk situations because you don't want to embarrass your company. And we have to augment them with a bunch of tools. For example, like retrieval augmented generation, where we give the large language model essentially a memory, and it can look at that memory and pull out just the information it needs to solve something or to answer a question, but grounded on the data inside of the retrieval augmented, or it's called a vectorized database. And so, we have to add all these additional tools to it to make it more powerful or capable. But a few more generations down the road, that could be entirely different. The stuff I'm aware that's being worked on right now makes these systems significantly more robust to these edge cases. It makes them much more capable. It makes them much better able to reason and to generalize, which is something human beings are really good at, but machines historically have not been. Essentially using analogies in order to, you understand a bicycle and how it works. If we had a bicycle riding artificial intelligence system, it would have to be completely retrained from scratch, or at least use transfer learning in order to ride a motorcycle. But we use analogies as human beings. So once you've learned how to ride a bicycle, controlling the motorcycle, you still have to understand the engine and stuff, is significantly easier than if you just had to learn it from scratch. So the next kind of generation of like multimodal models are probably going to, well, almost certainly going to be much better at generalizing across tasks they've never seen before.
That makes sense. So as a developer, I've been thinking about, I guess, honestly, I have this sort of nervous feeling that I don't understand AI well enough. And I think that's partially this feeling of what level of abstraction should I be comfortable with? So to give you an example, I could go out to Azure and I can find a bunch of LLMs or different AI. I'm not even sure the jargon is. They have a bunch of services that are labeled under this AI umbrella where I could have it do things like parse data and give me certain data out, remove PII, those sorts of things. And I look at that and I go, that's as simple as me making an HTTP request and I get what I want back.
Yeah.
So I don't really need to understand how the sausage is made. It just magically works. I pay the bill, happy. That's easy for, I think, any developer to digest. I look at a list of things that I can do. What do you feel like developers actually need to understand about AI beyond this, I call a service and this magical thing gives me back information?
Well, a couple things. I think I look at it as a spectrum. Like on one end of the spectrum, we have essentially pre-trained third-party models. What you're referring to, where Microsoft's got a custom vision service or a face detection service. You send in an image through an API call, you get some rectangles back with some labels and stuff like that. So that's the easiest way to get into this, and you really don't need to know a whole lot. Because they've already put all the guardrails in place for you. There's still stuff you need to know, but that's for another conversation. In the middle here, we've got something we call transfer learning, where say Microsoft's got like a vision service, but you need to have it detect your company's logo, and it can't do that out of the box. So you give it a couple examples of your company's logo, and you fine tune the model to be able to detect your logo. So all of the stuff about learning how to see the world, lines, geometry, geometric primitives, detecting faces and shapes and stuff like that, Microsoft's already taken care of training that. All you're doing is saying, here's the specific products I need you to detect or the logo I need you to detect. So that we call transfer learning. And that still doesn't require a whole lot of knowledge for the developer to build one of these solutions. A lot of it's drag and drop now. Then on the further end of the spectrum, in terms of difficulty, we have the like custom do-it-yourself machine learning. And now this is essentially what we typically would just refer to as machine learning. We have a set of data, we feed it into a machine learning training algorithm. The algorithm builds a model of the data that then allows us to feed it new data it's never seen before, and it will make a prediction. So for example, if you needed to use your customers' historical data to determine which customers you should approve for loans or which customers are going to churn or any of these kind of things, when it's your data and you have to build it based on your data from ground up, that's where you're going to need to know a lot of skills. There are so many ways to shoot yourself in the foot. You need to understand statistics. You need to understand how to measure the effectiveness of these models, measure bias in the models, just a whole slew of things. So it gets the scale doesn't look that long, but the amount of difficulty grows significantly the further down that side you get. Then the furthest down, you've got AI research, but there's, that it's just a whole nother level of complexity and difficulty. Doing good AI research is extremely difficult.
So that idea in the middle that you brought up is the one that appeals to me, especially this idea of I have a corpus of knowledge, whatever that may be, and I would really like an AI to parse all of that and build a model around it. What I'm unclear about is it seems like a hard problem. I don't know whether there are simple solutions out there that you happen to know offhand, or if this is sort of a specialization that some people know about. What do you know about that particular area? Is there an easy way for a layman to solve that today?
Well, once again, I think it depends upon what kind of problems you're trying to solve. And I guess all of this should be caveated by it depends on what type of problem you're trying to solve. And it depends on other things too. But for example, if you've got like a large like knowledge base of text, we'll use an example of something I've actually done. So on my website, I have, hundreds of different articles and, videos, transcripts, presentation, slide transcripts, notes, and stuff like that. So a lot of text. And I answer the same questions for people over and over and over again. So about 1 to 2 years ago, I decided to sit down and see, could I automate this? And so using a large language model, is GPT 3.5 at the time, and retrieval augmented generation with a Pinecone vectorized database, I took every one of my articles and I broke them into paragraph by paragraph chunks, stored them in the vectorized database, and then had a large language model. Whenever it got a question from an outside user, it would find all the keywords, vectorize them, make a query of the vectorized database, pull back paragraphs that were the best matches for the question being asked, and then you instruct it through the prompt, only answer the question if you can provide a source. Always provide the source after your answer. And if you don't know the answer, just say you don't know. And so simply by doing those things, it gets really good at grounding itself in factual information. If it's something that I said, they will only answer the question if it can find me saying something. And then all it's really doing is it's rewording it, taking three different answers and synthesizing it together into a coherent paragraph. But it rarely ever deviates from the answer enough that I would consider it being incorrect or a hallucination of some kind. So like that's just one example of like how you could build something by taking these pieces of things that already exist and putting them together to solve a problem in a unique and novel way. And you can do the same thing with like computer vision as well too, or you could do it with like, I mean, all the things that have popped up with like music, sound recognition kind of stuff. There's just all sorts of ways to take these things somebody else has built, put them together, and solve a brand new problem no one else has ever solved before.
I want to draw attention to a couple of things that you said in there. One, you'd mentioned retrieval augmented generation, which some people call RAG. And my understanding of it is it's basically saying, how do I get current information into my model? So
current information or correct information. So the ways a lot of people are using it is just to make sure it can query up-to-date information, because the model, when we train it, is trained on static text, and it's usually 6 months old, like a snapshot of the internet from a year ago or something like that. But you need to know, well, based on the latest sports, data, who won the World Cup or something like that. And so that's where it would be able to make a query to a repository to get that information to then answer with the correct updated information. But in many cases, you've got companies that just have giant tech support databases where it's like, we've answered all of these questions a dozen times before. We just need to pull one of the correct answers and then, synthesize it into an actual conversation with an end user. Because, the old chatbots were very strict. I mean, they were very fragile. If you asked a question in slightly the wrong way, they couldn't handle it. And so if you have the flexibility of a large language model, you can handle a lot more cases than with those very old brittle chatbots in terms of tech support.
Got it. So then this whole idea of RAG is basically a given, my understanding is, with all these new models. Is that fair?
No, it's something you have to add in. If you're using like Microsoft Azure services, they've got it kind of packaged around OpenAI services. If you do it through, I believe it's Azure AI service, but otherwise you add it yourself. And nothing against Microsoft. I am a Microsoft MVP and RD, but their solution to vectorizing data or making a retrieval augmented generation database is to use Azure Search. But I found Azure Search isn't anywhere near as easy to get up and running as something like Pinecone. Pinecone's just super simple. API calls, you get the data back. But from my experience using Azure AI Search, and keep in mind, it's getting better every month. When I used it last, there was still a lot of overhead to get it to work the way I wanted. But now, as I mentioned, since they have the kind of out-of-the-box turnkey solution to retrieval augmented generation in Azure AI service, it's a lot easier to do, because there it's just like drag and drop documents or point it to a blob storage or something like a CosmoDB database or something like that. And so way easier now than it was if you don't have to directly work with Azure AI Search. That's largely an enterprise solution.
Okay, got it. You mentioned Pinecone, and I'm not familiar with that.
So Pinecone's a vectorized database, much like what they added to Azure AI Search, kind of tacked it onto the side. A vectorized database essentially just means, let's see, what's the easiest way to explain this? So you've got words, and we break words into tokens, which are either a whole word or subword, like prefixes and suffixes. And so each of those tokens is embedded in what we call an embedding space. The best way to explain it is, imagine you've got a two-dimensional grid, and like over here's the word cat, and here's kitten right next to it, dogs over here, and puppies here. So things that are similar to one another are close, and things that are further apart semantically are further apart in this space. But instead of it just being a two-dimensional grid, this is like typically there's 1,000 some plus dimensions to it. And so you get all of the semantically similar things close to one another and all of the different things further away. So when you're vectorizing this, you're essentially just saying, okay, take the vector, the arrow pointing, if it's two-dimensional space, the arrow to puppy would be right here, and the arrow to kitten would be here. And then you measure the distance between the vector to kitten and the vector to cat, and they're close to each other, but the vector from cat to dog is further apart. And so those vectors are now in 100 or some or 10, sorry, thousand some dimensions. And it's just a long string of numbers. But you can then take a new set of tokens and as a query, send them off. And then you're essentially just doing the math. Which vector is closest to this vector? And it will just pull those vectors back, which is essentially the answers to your query, which are just a bunch of text, paragraphs of text.
Got it. So it's sort of metadata that connects different pieces of data and how closely they relate to one another.
Yeah, I think that makes sense. I mean, you could make analogies to like set theory and Cartesian stuff in databases, but yeah, it's essentially just doing the math to compute the similarity of things.
Okay, cool. So I wanted to go back to something that you said earlier. Like I couldn't help but think about as you were describing your vision of the future and with AI agents, with prompting them, with the way that we might be working as software developers in particular. When I look at that future, I think about how starkly different that is than where we are today in a number of ways. Like one of the things that I would notice is if you're in a situation where you're giving more or less plain English verbal commands to a machine, and for that matter, you could just hit the microphone and start talking. We've had that technology for a long time. It may look that way, or you could type it, of course. But the point being, if I'm in a world where I'm giving those sorts of commands, it doesn't strike me as particularly technically challenging anymore. Like things like syntax start to fall away. Things like strongly typed versus dynamically typed, things like APIs and all the geekiness that you and I have been used to throughout our careers. How much do you feel like that stuff melts away and we end up just in a situation where the LLM is picking the technology stack? Can you envision a future where we are at that point?
Well, I guess my first thoughts are, I don't miss assembler. I don't miss managing threads. I don't miss pointers and references. I don't miss memory management, garbage collection, like doing that stuff by hand.
Amen.
Like all of these abstractions we've added on have just made things easier and make me want to develop software even more. In fact, as another example, so I've had this idea kind of in the back of my head for about a decade. I'm like, I want to build this VR or at least three-dimensional history explorer where I can essentially just move through time in like, a corridor, like a museum, but everything's located according to the map. So like, the Greeks, and then all of a sudden the Romans take over and you're literally just kind of moving through and these things are passing by you and you can look around at it to really understand history because you're walking through history. And I'm like, oh, that'd be so cool if I could do that. But it was one of these things that I knew it'd be a month just to get started. And so now with like, Visual Studio Code's plugin with, GitHub Copilot and with, using GPT-4, I literally did this in a couple of days. I don't know much about Unity. I took a workshop on it maybe 9 years ago or something. So I barely remember any of it, just enough to be dangerous. And it and I worked together as a pair programming team to solve this in a couple days. It was ridiculously impressive how I was working is still in C#, but in an environment I didn't understand, doing things like, oh, what's this thing called? Oh, blah, blah, blah. And it tells me the answer. Oh, well, how do you make it do this? Oh, we'll just do that. Well, it didn't work. Oh, well, you did it wrong, and the feedback loop of building this was so tight. I was able to complete it in, I don't know, a few days, at least to the point where I could see, is this actually worth investing more time in? And, oh, yeah, it's cool. I'd totally invest more time in it if I had more time. But I got enough of it done that it satisfied that curiosity in me of always wanting to know, could this be done? And, it's not production quality, but as a proof of concept, throwing it together in 3 days, that's something I could not have done even 3 years ago. It just would have been impossible to do it that quick.
So that speaks to obviously the benefits to it is it's like any time that we get more power, more expressive power, we end up having higher expectations, we end up getting higher velocity. And I think part of the honest question that I have is how concerned should I be as someone who has enjoyed a lucrative software development career? Are we moving into an era where you may not need a degree anymore? Well, you haven't needed a degree for a long time. Let me backtrack that. Where you need not have real technical expertise to be able to write software anymore. Is it realistic for the layman in the near future to be able to implement things like you've just described, just based on being able to speak it into existence?
Yeah, I think a lot of people would have said like the low code, no code movement would have never panned out. And I mean, I'm seeing some really impressive stuff in that space right now. I know people who do data science that, we don't want to spend time having to figure out how to use the new data visualization suite. So you literally just say, hey, create me a graph with this data,
Yeah.
XY plot and trend line kind of thing. And it literally just writes the code for you. And then you just iteratively do that rather than spend your day writing the code just to find out this is a waste of my time and I should move on. So if you're the kind of person that enjoys the ritual of software development, I think you're going to be terribly disappointed in a few years. But if you're the kind of person that likes software development because it solves problems that you find interesting, I think you're going to love being a software developer in the future.
I really like that framing. And honestly, oh man, that hits me in a way that I've actually not sure how to answer that. Like I love the act of feeling like, okay, what is the syntax? What is the pattern? What is the library? All these sorts of little decisions, and thinking of through all this stuff I've learned through the years, how do I put all this together?
Yeah.
And I think of myself a lot like, any other craftsperson would,
Yeah.
where you've got all this experience. And that's part of honestly, that's part of what stemmed this. That's why I wanted to have this conversation with you today. Cause really I'm dealing with an existential crisis, just seeing how good AI has gotten recently, like jumping into using a lot of different LLMs and seeing how much faster I can code, and then guessing where that's headed, because obviously this is not the end game.
No,
it is as
no,
bad
not
as
even
it's ever
close.
going to be. It is definitely going to get better. So and to be clear, I think it is pretty obviously a net win for humanity, but it may not be a net win for my career. That's what I'm torn on. And I know like you're focused on AI research, so you're a happy, busy guy,
Yeah.
and you are in the absolute right place at the right time. And it's funny because, we've been friends for years. There was a time that I looked at what you were doing and I thought, I don't know if this AI thing's going to play out. It seems like just a bunch of hype, but it just turned out you were slightly too early. And now your early timing actually ended up paying off wonderfully.
That has been the story of my career. I was always working on the thing that didn't have a name yet, or wasn't in the, didn't blow up yet. I was working on geographic information systems before almost anybody else had heard what they were. I did IoT before we even had the term Internet of Things. I was doing data science before there was even the name data science. We were just doing data analysis or whatever, and data engineering. And then I was working with machine learning before most people knew what it was. And the same thing with AI. So it's been my whole career, always a little earlier on the trend curve. And then I move on. I get bored and I move on to the next thing before it typically hits peak height.
Makes a lot of sense. What is your career advice to somebody who's writing code in a traditional way today? Obviously, we all are trying to pick up, okay, I need to use an AI to code. I assume you would agree with me. That's a given. If you're not using some kind of AI help, you're just holding yourself back at this point.
Yeah, I completely agree with that. And we refer to that as like a centaur or a transhuman or hybrid system, where it's you working with an AI, because the two of you together are much more productive than either of you alone. And the way I like to think of it is it's like pair programming, and I hate to use the term pair programming with an idiot savant. Like your pair partner is really good at a lot of things, like super OCD, detailed, will pick up any bug just by looking at it. And you're good at other things that they're terrible at. And so putting you two together on a team makes you way better than either of you as individuals. And so if you're, in the space right now as a software developer, questioning, what is the future going to look like? I think it's one of two things. Either you learn to embrace change and you get ahead of the curve, adopt these technologies, learn how to use them in the ways that are most beneficial, and avoid the hype and the ways of using them that are not beneficial. Or, and this comes back to the presentation you used to give years ago about the early adopters and the laggards, you figure out how to become a niche in the old technologies and then just maintain old code bases. There's still mainframe programmers out there. Like I know guys that write COBOL on mainframe systems. They make a lot of money doing it because the mainframe systems are so deeply integrated into the insurance and banking world that they'll probably never be able to get rid of them. I mean, maybe not ever, but they're going to end their careers. Like their careers will, they will still be writing COBOL when they finally retire out. And so there are places to still fill that niche. But I mean, I don't want to write in Fortran. I don't want to write in assembler. I don't want to write in Pascal. Like any of these, older programming languages or paradigms, I would feel so crippled, I think, so constrained because for me, software is a means or coding is a means to solve a problem I'm interested in rather than me finding problems because I have code. Maybe that's not the right way to word it, but I think you get what I'm saying.
Yeah, I do get what you're saying. I think what you said earlier resonated with me when really it's about solving problems, not about the tech itself. And the tech has always been exciting to me because I thought, okay, I get to build something useful for someone else. And so learning this new language or this new library, that's why it's exciting. If no one else found what I created useful, then I'm just playing a game at that point, which games can be fun in their own right. But that inherent value is at least important to me.
But I also get, we have invested a large part of our careers in, what we know, what we're experts in. And, we also have the dopamine feedback loop that is kind of tuned now to developer productivity. Like when we're pair programming, for example, I find highly addictive because the dopamine feedback loop is so tight. And so when I am not doing, test-driven development, not pair programming, when I'm not doing test-driven development, I don't feel that dopamine feedback loop in the same way, but sometimes TDD is right and sometimes it's not. If I'm building a prototype, there's no way I'm going to invest the time doing TDD to just, is this thing going to work or not before investing time? But I'm also not going to use the techniques that I use for building a rapid prototype to build production software. Two very different things. So I personally don't feel like I'm missing out by not being able to employ these skills for this problem or these skills for this problem. I'm just glad I have those skills in my tool belt, whether I actually need them or not. And, over our careers, they've changed so much since when we started. I think the thing that you have to get really good at is embracing change. Like that's the skill you really want to be invested in, is being able to learn something new as quickly as possible, teasing through all of the different ways to learn it and all of the snake oil salesmen out there. Learn it, solve the problem, and then move on to the next problem. But that's not for everyone. I mean, I recognize there are a lot of people out there that don't want to have to spend the weekend learning a new framework or technology or skill set. They just want to keep doing what they've been doing. And, to an extent, you can do that. But at some point in time, I mean, we don't buy handcrafted chairs in mass quantities anymore because the factories can churn, much cheaper, good enough versions. But there's still guys that will spend an entire weekend making a handcrafted chair because somebody wants it and they love doing it.
Absolutely. So that'll continue to exist. It is weird thinking about that going into the sunset to some degree. Okay, so I'm curious. We've got all these different ways that we could use AI today. What do you feel like are the most exciting things that a developer could do with AI today?
So I think it would go back to something I mentioned earlier, using all of these things that the AI researchers and Microsoft and OpenAI have already put together to put them together in a way that solves a completely new problem that no one else has tried to solve yet. I think there's tremendous value in somebody coming in there and building, like when you think about Uber, like when someone finally decided, hey, let's solve the taxi cab problem by putting all of these different pieces of technology together in a new way. I mean, they created an entirely new market, wildly successful, changed the way we, hail a taxi or, transportation, have changed it forever. Airbnb is the same way. There's just numbers of these like ideas where somebody just took a bunch of things in the AI space or the computer science space or the internet, space, put them together in a novel way and then made something amazing. So I think if I were not doing AI research, if I were just doing software development right now, I think that's what would get me most excited, is figuring out how to solve a problem using all these tools that have, been prepackaged for me. I don't know that I would be super excited to try, training my own computer vision models from scratch. I mean, that problem's been solved, and the amount of time, energy, and skills to do that stuff is very high. Like, I know how to do it, but I've been doing this for a couple decades now. Whereas,
Mm-hmm.
as a software developer, if I hadn't invested all of that time, that's not the kind of thing I would be interested in tackling. I think you either go the route of becoming like, an AI engineer, a machine learning engineer, or you go the route of being a software developer using the tools that those machine learning engineers and AI engineers have put together in novel ways.
Right on. Have you noticed any specific common mistakes that developers are making today?
Specifically with AI,
Yeah.
I think it's not just developers, but everyone in general, overestimating their capabilities, not spending the time to learn what their capabilities and limitations actually are, and not doing enough to prevent hallucination. Because these these large language models, they like to hallucinate. Which, for anyone that doesn't know, that's where these large language models will make up information that sounds completely plausible, and they will be very confident in doing so. For example, at one point in time, I had to find like 5 research papers for some topic in AI that I could, then read and do some research on. And so I just asked large language model, hey, give me the top 5 papers on self-reflection in large language models or something like that. And it gave me a list of papers back. It had the paper's title, the author's names, the journal is in, the page number it could be found on, the volume of the journal, for all 5 of these things. 2 of them I looked up actually existed. The other 3 completely, entirely made up. The journal existed. The paper did not. The authors oftentimes did not. And even going to the volume and page number of that journal, they were not there. And
Mm.
so, but like if I hadn't double checked that, they look completely legit. So you have to really double check everything that these large language models do. And you as a human being have to put the guardrails around them right now. It may not be that way in the future. Like when we have self-driving cars that are safer than any human driver, then having a human being overseeing the system or in the loop will actually be disadvantageous. But right
Mhm.
now, if my car on full self-driving mode beta, uh, I have to watch that thing every turn and stuff. Because even just yesterday, for some reason, I'm driving through road construction, and it normally sees road construction cones. They were just completely invisible to it for some unknown reason, and it was going to drive straight into road construction. So I took the wheel and I reported a bug. Hey, it couldn't see the road construction cones for some reason. And who knows? I mean, it was probably just a computer vision glitch, or maybe the cameras had a bit of dirt on them or something like that. There's some plausible reason why.
Mhm.
But right now you have to oversee these systems. But in a few more years, I mean, it may just be that they do a better job than we do as humans at software development, and we stay out of their code. Hell, they might not even write in code that we can read anymore because it's not efficient.
Yeah, I heard that. That brings up a very interesting piece of conversation that we might be at the end of traditional programming languages. That if we're now moving in the direction of increasingly prompting AI to do these things for us, why would we have a language that is optimized for us keying it in line by line and reading it that way?
Well, the answer is transparency. You really need to understand what these models are doing, or these AI systems are doing. And in terms of writing software as their goal, the best way we can determine that what they're doing is good is by inspecting the code that they write. Because right now they're black boxes. We can't look into large language models and say, why did they decide to write this word instead of that word? The math to figure it out, we can't comprehend. We could calculate it and see, well, this is why it got that answer, but we just can't look at the models and figure it out. They're developing tools that make these models more transparent, where you can kind of probe their brains to see, oh, well, if we probe here, then all of a sudden, every time we ask it a question, it seems to move towards the Golden Gate Bridge or something like that. So you're asking a question about, oh, what's the best state to visit? Oh, well, San Francisco, because of the Golden Gate Bridge, because you're touching the Golden Gate Bridge nodes in its brain, essentially. So we're getting better at being able to probe these things from the inside. But at
Yeah.
least for right now, as long as human beings have to oversee software development and are legally liable for what the software does, we will have to have code in human readable language. But once again, like with self-driving cars, at some point in time, if these things get better than all human beings, are driving on the road, and like 10 times better, 100 times better, having a steering wheel in the car is actually more dangerous than not having one. And it'll be the same way with software, but they have to be 10, 100 times better at not making bugs and writing reliable, safe code. And the laws would have to change too, so that the liability, I'm not sure how that would work. But we'd have to have that before we take human readable code out of the equation.
Got it. So I'm curious. I know you travel around, you speak all over the place. When companies have you come in, I'm assuming that you're normally talking about AI, obviously given your focus. What value are they hoping to get out of that conversation?
Well, typically when I'm brought in, it's for one of two things. Either the company has kind of kicked off an AI like transformation plan, and they're bringing me in to either teach basic AI literacy. Oftentimes, I'm just kind of giving them a tour of the landscape of AI, showing them here's the kind of things you can do, here's what exists, and here's what problems they solve. I do training on AI ethics as well. They usually a bit more advanced because they're already working their way through their AI transformation. And then on the other side of things, other than the kind of basic teaching and training, I'll be brought in for consulting kind of things where, the executive leadership is trying to figure out something with AI business strategy, or more likely it's, they're trying to figure out, is this even possible to solve this problem? So I'll either just give some advice based on what I know exists and what doesn't exist, or what I know works versus what doesn't work. Or if they really need handholding, I can go in, build a rapid prototype to see, is this even possible? And as long as I can prove that it's possible, then oftentimes it's worth investing in. But if I'm like, I spent 2 days on it, there's just no data. There's not enough data to make this work. Maybe in 5 years you'll have enough data, but right now I can't get the accuracy above 30% or something, or 50%.
Got it. So I don't want to put words in your mouth, but if I were to summarize our conversation here, it sounds like you see the future of software increasingly being more like a product owner / product manager / maybe even a UI designer. I mean, obviously there's still going to be these specializations to some degree, but the developer is going to increasingly be operating in those sorts of capacities. And so there's sort of an open question longer term. I can see a picture of a future where developer teams are much smaller than they are today because you can accomplish so much more. It's no longer a headcount issue. It's really an idea issue. And frankly, that's exactly why I'm concerned about the future, because I go, okay, if we need, say, half as many humans to do this job, what happens to the other half of the humans?
Yeah.
Does that sound like a likely future to you? Am I characterizing your...
It is a genuine concern. I think in terms of software development, if you want to continue moving forward as a software developer, I think you need to accept the reality that your job is going to be more of a highly technical product manager or manager of some kind. You will literally be managing a team of these AI agents building the software, and you're essentially just making sure they're doing it the right way and nudging them in the right direction. However, you can also move in other directions, like lateral directions. There's opportunities to move into machine learning. If you're really interested in the idea of building these models that the developers are using to solve these problems, you can move into data science. It's tremendously interesting stuff happening in data science. I did it before I went into AI consulting, I was a data science consultant for a decade, and then a software developer for the decade before that. But there's also opportunities as like AI engineers. So, like doing stuff more on the cutting edge AI, because machine learning, is a bit older now. And there's data engineering. There's a whole bunch of other ways a software developer can go that are still close to what they love about technology, but are adaptable. They're following the technology trend if software development as we know it eventually disappears. So I think there's still tremendous opportunities for software developers going forward. The trick is you need to be preparing for this with realistic expectations, avoiding the hype, and adapting to change, as it's changing around you.
Wonderful.
But that also does bring, the larger economy, the labor economy into question. So, like in terms of technological unemployment, which is a genuine concern of mine, In fact, if I think about the three biggest risks of artificial intelligence in the short term, it's misinformation, like deep fakes, computer generated misinformation on scales that we've never seen before with large language models and stuff. In the middle is technological unemployment, essentially jobs disappearing because they're being automated quicker than we can retrain society. And then on the further out end of the spectrum is the AI, the value alignment problem. How do we ensure that humans and AI continue to have aligned goals and values, which is a really difficult problem. And that's where a lot of my AI research is focused right now. But in the medium term, after we get through the election cycle of misinformation and deepfakes, which I thought would be worse this year than it actually was. So I think as long as we can get through this election cycle, hopefully it'll buy us another 4 years for people to actually learn what information to trust and what not to. But that's probably another conversation. So in terms of the labor market, right now, McKinsey Global Research, they estimate that 600 million jobs will disappear by 35? I can't remember. It's something like 16% of all jobs, global jobs right now, will be gone within a decade. And so, but they're also predicting that 700 million new jobs will be created as a result of this new wave of technology. And so that's like 20% of all jobs in the economy. So hopefully we're going to end up with 100 million more new jobs that didn't exist before. So there's going to be opportunities for people to transition. The trick is this is going to happen so fast that we're not ready for it as a labor market, as universities retraining people, businesses needing to find talent that has these skills, our government and safety nets like unemployment. None of it is ready for this right now. And it's going to happen, it looks like, within a decade, which is the fastest labor transformation we've seen in human history. The Industrial Revolution took easily 100 to 300 years. This is going to happen in like a decade if these predictions are correct. And so that's a genuine concern of mine. But even though it looks like there's going to be 100 million new jobs created, which is 5% of the labor economy or something, there is no guarantee that these 100 million 700 million new jobs being created, that AIs won't be able to do them better than humans will right now. So there's a real question as to whether there will actually be enough jobs for everyone in the world. Historically, anytime we've gone through one of these transitions, we've always ended up better off than we were before. Like, before the agrarian age, survival rates were pretty low. Then, being a peasant farmer was kind of a crappy deal until you get to the Industrial Revolution. Being a factory worker in the Industrial Revolution was kind of a crappy deal. But then you get to the technology revolution. And eventually you get to a point where, we have all of these great things around us, but there's also a lot of negative externalities from it. And, we've survived as a society, but each labor transition was really tough for some people and really great for other people. And so the hope is that this ends up benefiting everybody equally. But the way society is currently structured and capital markets are currently structured and labor markets are currently structured, that will not be the case unless we do something different than what we're currently doing going forward.
It's an interesting future ahead.
Yeah.
Lots of
it's coming fast.
Challenges.
It's coming really fast.
So I'm curious, as a developer, what would you suggest I read? What resources have you seen out there? What should I go learn now to prepare myself for this new era?
Well, I know I'm going to sound self-serving in saying this, but every one of my online courses I've created at part of my journey where I felt I was an expert in X, but I just needed to know that last 90%. So I would create the course in order to teach the person after me, hey, here's how you learn this as quickly as possible and not have to spend 10 times as much time learning it like I did. And so all of my online courses, I have everything from a free course on preparing your career for AI. I've got all my Pluralsight courses. I've also got presentations. Every presentation I have, there's a free video of it online. Everything from developing, your AI business strategy, ethics of AI, AI Developers Toolkit. It's actually called AI for Everything. It's a survey of the landscape of everything you can do with AI. And my most recent presentation is on artificial general intelligence, which is essentially human level AI capabilities. So essentially, how did we get to where we are today? How far do we have to go to get to machines that are as good as humans at roughly 50% of all tasks. And where are we going after that with artificial superintelligence? So I think if I had to start somewhere, I would start with my online courses, and then I would work my way out from there, because I also point people at resources if they want to dig deeper into these things.
Good stuff. And so to find all of that, I go to MatthewRenze.com.
MatthewRenze.com. Yep,
Bingo.
MatthewRenze.com.
Okay. All right. So last question. Are you optimistic or pessimist? I recognize that it's hard to say this in a binary, because I mean, our whole conversation has been interesting to me. There's parts of it that you described that get me really excited about the future and what humanity is going to be able to pull off. I think it's a net win for humanity to have more people who are able to take an idea in their head and manifest it. I think that's fantastic. And that's sort of been the story of software throughout the ages. It keeps getting more approachable to people. At least I think so, although one could argue maybe not, because expectations keep climbing along with our tools getting better. But this is the thing where now, man, it sounds like the great equalizer. It really feels like we've got this utopian future where people will be able to take their ideas and a computer can help them make it a reality at a level that we just right now, we haven't seen anything like it before. But there are some real concerns in the future.
Well, I have a couple of thoughts on it. First, my wife and I have a nonprofit organization where we essentially teach people tech skills in parts of the world that don't have access to good technology education. And what I can say is that, we have students in places like Nigeria, India, Pakistan, places that really don't have access to good technology education programs, or they don't have the financial means to do it. And through the tools that we now have available through online courses versus AI tutors and stuff like that, they're able to learn how to write code, like develop software, and get jobs doing it. And these jobs, even 5 years ago, these jobs would not have been within their reach. Just flat out, there would not have been a way for them to do it. And they tell us that story. I'm not saying that they are telling us that story. And so I think there are tremendous opportunities for what's coming for people interested in getting into software development, people that are interested in going from software development into this new AI project management or into other technology tracks. But in terms of the cons, and I would say that I'm highly optimistic and I'm highly pessimistic. I don't feel like I'm in space. I feel either things are going to go really good or they're going to go really bad. But historically, things typically take a middle path. The way it feels to me right now, and obviously I wasn't around when they invented the atomic bomb, but I bet it feels a lot like that, where we're on the verge of an amazing technological breakthrough. Some people are looking at it like, this is going to open up energy sources we have never had. Society is going to flourish. This is going to change everything for the better. And other people are looking at like, this is going to unleash the most destructive force humankind has ever known. And I'm guessing the same way, there probably weren't a whole lot of people in the middle. You either think this is going to make the world a utopia, or we're going to end up with World War III nuclear winter kind of situation. And so I feel the same way with artificial intelligence. I think this will be humanity's last invention, either because after we create AI, it essentially is better at inventing new things than we are, or because we're not around anymore to invent things. But, I try to be as optimistic as possible, but I'm realistic. I recognize that there are some very serious issues we need to work around. And so that's why I spend as much time as I do trying to, research AI in ways that are going to be beneficial for everyone.
Humanity's last invention.
It's not my quote. I got it from somewhere. I just don't remember where.
It's a fascinating idea, though. And it's interesting because it's both optimistic and potentially pessimistic, depending how you interpret the whole thing. I think everything that you said jives with me. And perhaps it even comes down to how you look at human nature itself. And the line between good and evil runs through the heart of every man. Like it's...
So that's another way to look at this. And I typically end most of my presentations with this. And it's that, technology is inherently amoral. It is neither intrinsically good nor evil. The exact same technology can be used to send mankind to the moon or to, push warheads into cities or propel warheads into cities. And so it's really up to us as individuals, organizations and a society to choose whether we want to use these, new AI tools, for our own, control and, to make the world a better place or to make the world a very not great place to live. It's up to us.
I think that's a great place to leave it. Matthew, thanks for coming on the show, man. This is fantastic.
Yeah, thank you for having me.